thanks for your attending our tutorial. Please mute your audio. And if you have any questions, please leave your questions in the chat room. And I will remind the speaker, or if I can, we can. So all the presenters will be here to answer your questions. So feel free to leave your questions in the chat room. And sometimes I will remind the speaker. So if we need the speaker to answer your question. Okay. So today we will talk about deep recommended system. Majorly we focus on the fundamentals and all the advances. So my name is Jinyan Tan. I'm from Michigan State University. I'm very happy to present tutorials with co-presenters Shan Rizal from Michigan State University, and he will join the CTU of Hong Kong as an assistant professor. If you are interested in recommended system or related topics, and you want to pursue your PhD or any postdoc or visiting students, you can contact him with him. And the other presenter is Wenqi Fan. He's also a research assistant professor from PolyU of Hong Kong. The same thing, if you are pursuing a PhD or related degrees, you can contact with those two young professors. The other presenter is Da Weiyin, Hulong Baidu. Okay. So I will majorly focus on the introduction. So I still remember when I was young, the information is relatively poor, and it's easy for me to get the information I want through TV, newspapers, and books sometimes. With the advances of technologies, especially like the smartphone or Web 2.0, the information and information resources become much richer. However, we at such area, we even become harder for us to locate the information we need. It seems more is less. The major reason is we are overloaded by information we have now. Correspondingly, there are two major technologies proposed to mitigate the information overload problem. So one is search. As we know, we have Google, Yahoo. In China, we have Baidu, right? So we give a query to the search engine. The search engine can locate the information we want from billions of documents. Another technology is recommended system. So recommended system wants to recommend some items to us to satisfy our information need. So of course, the definition of items can be very diverse, can be products, news, movies, videos, and some people or friends. So here, actually, recommended systems are everywhere in the online world. We often use them in our daily life. Next, I will give a few examples, probably we are all familiar with. One most important application of recommended system is e-commerce, right? Like Amazon, JD.com. So they are B2C, business to customer platforms to sell products. And we also have the C2C, from customer to customer, like eBay, like Taobao, right? So we can directly from customer to sell items or products to our customers. So especially during this pandemic time, we cannot go to the stores as usual. So we will do a lot of online purchase behaviors. So even for one product, there are so many choices. So which one we want to purchase? So in this case, in this scenario, recommended systems can help. So the second popular service is content sharing, right? So we have the video sharing services like YouTube, TikTok, and also we have image sharing services like Pinterest, and also, of course, the most popular is news, like Google News, ByteDance. So I think that so the technologies change our life behaviors. So let's go back to when I was young. At that time, so who can produce content is very limited. It's typically from those newspapers or from very, professional authors that wrote some blogs or news. So the information resources are quite limited, but now everybody can create content. For example, TikTok, right? Everyone can create a content. We can share any videos we want into TikTok. So which video we should watch? So in this scenario, the recommender system can help. So the last one I want to share is social media services like Facebook, LinkedIn, and Weibo, like Chinese Twitter. Basically, for Facebook, we have more than 1 billion of users. So who we should connect to, right? So we cannot browse the list of 1 billion users to make the connections. So in this scenario, recommender systems can help. So once we go through those recommender systems in our daily life, and also recall a lot of technology like a search engine, right? For search engine, typically we will give the system what kind of information we need, so which is encoded by queries. But in recommender system, we don't explicitly give such information to the system. Then we were wondering how recommender systems can work. So actually in real world recommender systems, we also have a lot of data which can help us to make the decision to make the recommendations. Here, I would like to use the movie recommendation as one example to illustrate what kind of information is available to help us to make recommendations. As we know, in the Netflix, right? So it's a very popular movie service provider. So in this case, so users can rate those movies. Say, for example, if this movie is very good, we give 5, and then we give 1. So we will use a 1 to 5 scale to rate the quality or the preference from customers or users to movies. Of course, in addition to these interactions between users and the movies, we also have some side information about both users and items. For example, for users, we could have some attributes information of the users, like the gender, occupation, education background, and even sometimes their social relations. For items, we could have their, the content information, like which year the movie is produced, so who is the director, who are the actors, and also a lot of users may leave some reviews, right? So although we don't explicitly issue the query information to encode or to provide our information needed in recommender system as a search engine, but indeed we have very rich information from our users, our items to use to make recommendations. So here we can formally say in recommender systems, so the data we want to use is some historical user item interactions and also some additional side information available for users and items. So there's no free lunch. If there's no data, it's very hard for us to make any recommendations. So the goal of recommender system is to predict how likely a user would interact with some given items. So in the news recommendation, so how likely a user will read this news or click this news. For product recommendation, how likely this user will purchase some items. Okay, so the major technical challenge for recommender system is rely on this available information. How can we learn user preferences just like the search engine case, the query, right? So how can we understand the user's information needed? So we have to learn such information from the historical data automatically instead of asking a user to issue the query to make some recommendations. So one most popular technology to build a recommender system is collaborative filtering, or we can use CF as abbreviation. So basically, so this technology, the underlying assumption of CF is if users are similar in the history, they will similar in the future. So we'll have similar preference in the future. And so the key here is how can we, based on the available data, to model user preference, and also sometimes we need to model the item characteristics. So there are two major categories of methods for CF. So one is the memory-based methods, right? So basically, in this case, we try to find similar users or similar items, and then we store those similar users and similar items. And in the future, when we want to make a prediction, so we can refer those similar users and items. So that's why we call this type of methods as memory-based methods, because we need a large memory to store similar users and similar items. Another popular method is model-based method. Instead of pre-calculate all this kind of similar users and items, we assume so that the user preference will follow some model assumption, and then we can learn the model parameters to make the prediction. So in this case, we don't need to store the original data. We only need to store the model parameters or something, right? So of course, the model-based method is very popular or widely studied or extensively studied in the literature. So majorly in this type of method, we will deload the user item interactions as a matrix, right? So for example, here we have an illustration example. So each row is a user, and each item, so each column is an item. And then we use the corresponding entity to deload the interaction between users and items. So in the movie recommendation case, we can use the entity to deload the rating scores. For example, so this user gave a 5 score to this movie. But and in other scenarios, for example, for the news recommendation, probably we can use click, whether this user clicks this pieces of news a lot. But in general, we can deload this type of information as a matrix. And then based on the matrix, we try to learn user and item preference, so this information is encoded as their representations. So one of the most popular methods in this category is matrix factorization. So the underlying assumption of matrix factorization is the user preferences and the item characteristics typically is low rank. So that's why we can factorize this matrix. Typically in real world, we have millions of users and also probably millions of items, right? So, but this matrix typically is low rank. So basically only a few factors can influence the user's preference or the item's characteristics. So that's why we can factorize this matrix into two small matrices. So one is the user latent matrix. So another is the item latent matrix. So in this case, each row donate one user, and in this case, each column donate each item. So since we project both users and items in the same latent space, so that's why the entity in each matrix in the matrix can simply calculated as the inner product or the similarity. Somehow we can call the similarity or matching between their latent representations. So this is typically what matrix factorization will do. And of course, when we, as I said, so we typically have the low rank assumption in this kind of model. So that's why we can say the number of latent dimension is typically much smaller than both the number of users and the number of the items. So then when we have this kind of model, then the next question is, how can we learn those representations automatically? So typically we will formulate this problem as an optimization problem. Basically, we have the ground truth. So basically, this is the observed behaviors of user and item interactions. And then this is the prediction. Of course, as I mentioned, the prediction is modeled by the inner product or some matching or similarity between the latent representations. So in this way, we can learn these latent representations or latent factors of users and items automatically. So once you use the observed information to learn those two matrices, we can reconstruct the original matrix through the multiplication of those two matrices. And then we can use the recovered entities to make the prediction for some missing values in the original matrix. So that's basically how matrix factorization can work for recommender system. Here, so one thing we can observe is, so if we want to make accurate prediction for recommendations, one key is how can we learn those user and item representations. So basically, those two representations will play an important role in recommended systems. So if we use a popular word in the area of deep learning, that means we try to learn representations of users and items. So when we mention representation learning, so typically, definitely we should not, discard deep learning. So basically, the introduction of deep learning indeed changed a lot of field automatically. So here I give several examples. For example, in the image lab, basically this is a objective recognition task. So when we introduce deep learning, we can say the performance dramatically improved by introduce the deep learning, and this performance continuously increase with advanced models. And of course, this is not just in this specific task. We have, so deep learning has advanced more fields and more tasks. For example, computer vision, speech recognition, natural language, and also recently we have this kind of neural graph representation learning. So naturally, we can say there are a lot of opportunities if we can adapt deep learning to recommend system. So that's the motivation of this tutorial. Basically, in this tutorial, we will cover how we can apply or adapt deep learning and its advances to recommend the system. So in the following talk, we will majorly have 4 components. So for the first component, we will majorly focus on the fundamentals of deep recommend system, basically the basic deep models to recommend the system and how we apply those models to advanced recommendations. And after that, we will introduce some advanced models in recommender system to solve different problems in recommender system. The traditional recommender system will face or encounter, and including reinforcement learning. How can we apply reinforcement learning to advanced recommender system, and also graph neural networks? How can we apply GNNs to recommender system? And finally, we will introduce how can we automate the recommender system. Okay, and here is the agenda of the remaining tutorial. I think after my introduction, Wenqi will introduce the fundamentals, and then Xiangyu will introduce reinforcement learning for recommendations. So after that, if we have time, we will take a break, like around 10 minutes. So then we will back for graph neural networks for recommendations and how can we automate recommendations. And finally, we will have a short session about the conclusions. And if you have more questions, we can continue. We will try to answer your questions. Okay, so that's a brief introduction about recommended system. So I will handle the presentation to Wenqi. Okay.